This section will describe the operation of the CSD and the generators, and their relationship to the controls and indicators. The engines operate at different speeds depending on requirements on the ground and during flight. However, the generators must run at a constant RPM to supply a constant frequency. To achieve this, each generator is connected to its engine through a constant speed drive, also called a CSD unit. The APU runs at a constant speed via its fuel control, and therefore does not require a CSD. The CSD is a hydromechanical unit with its own lubrication system. It maintains a constant generator speed from engine idle up to takeoff power. During CSD operation, the oil temperature in the CSD increases to approximately 100 degrees Celsius, which is normal in flight. To cool the CSD, the oil is passed through an oil cooler located in the engine fan duct. The temperature is monitored at the CSD outlet to the cooler and displayed on the inner scale of the temperature meter located at the top of the electrical panel. Abnormal temperature limits are indicated by yellow and red bands. Another temperature sensor is positioned at the CSD oil inlet. Readings from the inlet sensor are compared to the readings from the outlet sensor. The temperature difference, or rise, within the CSD is then displayed by pushing the CSD rise button. Now touch the button to display the temperature rise. The pointer shows about 6 degrees rise on the outer scale. The yellow marker on the outer scale indicates the caution zone. When the button is released, the indicator reverts to its original function, indicating the oil outlet temperature. There is a CSD oil annunciation on the overhead annunciator panel. It has two functions. It monitors for high oil temperature and low oil pressure. The annunciation comes on if there is a malfunction in the CSD or when the CSD is not in operation. For instance, when the engine is not running. To avoid having a malfunctioning generator or CSD connected to the engine, the CSD drive shaft is equipped with a disconnect function. Note that the disconnect function receives electrical power from the other side. The CSD can be disconnected by using this switch on the overhead panel. The switch is guarded to prevent inadvertently disconnecting the CSD. Touch the guard to disconnect the CSD. When the guard is raised, the switch can be set to disconnect. It should be held in disconnect for at least 3 seconds. The switch is spring-loaded back to normal. The pilot cannot reconnect the CSD unit in flight. It can only be reconnected on the ground by maintenance using the reset handle on the CSD unit. The aircraft has 3 identical AC generators, each capable of producing 40 kVA. First, let us take a look at the engine-driven generators. Each 3-phase generator is controlled by a generator control unit, or GCU. The GCU includes a voltage regulator, which controls the generator voltage. The Generator Control Relay, or GCR, will provide protection for over and under voltage, under frequency, or a shorted circuit. The GCR will automatically trip and disconnect the generator for these malfunctions. Pulling the engine fire handle will also trip the GCR and disconnect the generator. The generator relay will open when the generator does not deliver any electrical power. The generator off annunciation on the annunciator panel comes on to indicate that the generator relay is open. The generator switches, one for each generator, are located on the electrical panel. They operate the generator relay and the generator control relay reset function. The generator switch is normally in on, which allows the generator relay to close once the generator is up to speed. Now touch the generator switch to move it to reset. The reset position resets the generator control relay if it has been tripped, for example, after a malfunction or if the fire handle has been pulled. The spring-loaded switch will now return to off. In this position, the generator relay is held open and the generator is disconnected from the electrical system. Set the generator switch to on. When the switch is in the on position, the generator relay will close and connect the generator to the electrical system. The generator off message will then go out. The voltage and frequency meters located on the electrical panel monitor the state of the selected power source. Normal operating values are approximately 115 volts, 400 Hertz. Note that the voltage and frequency can be monitored even when the generator switch is in the off position. Each generator has a load meter. Load is indicated when the generator is supplying power. Its normal operating limit is 1.0 for continuous operation. Overload is acceptable but time limited. That completes the engine-driven generators. Now let's look at the APU. The APU also has a control unit. The generator control relay will trip for a malfunction or when an APU fire is sensed. Its generator control switch has two positions, reset and normal, and is spring-loaded to the normal position. The reset position sends a reset signal to the generator control relay if the relay has been tripped. When the switch is released, it will drop to normal. The APU generator voltage and frequency are indicated on the common meters if the APU position is selected, and this meter indicates the present APU load condition. Good. Yes. Yes. Well done. Good. This section would examine how the electrical system is energized in terms of the power priority system. The sequence using the relevant controls and indicators will then be reviewed. External power has the lowest priority. In this instance, the engines and APU are not yet started, and their generator relays are open. All consumers are powered by external power. When the APU is started, the external power is automatically disconnected from the buses, as the APU has priority. You will notice a short power interruption during the changeover. The APU generator is then connected to the left and right systems. When the first engine, normally the right, is started, the APU generator is automatically disconnected from the system, in this case, the right system. The engine generator takes over. However, the APU is still supplying power to the left system. Once the second engine comes up to speed, the APU generator is disconnected and the engine generator is automatically connected to the system. In flight, each system operates independently. Paralleling can never occur. Let's now review the sequence with the controls and indicators. When on, this light indicates that external power is connected and available to the system. The external power bus switches allow both systems to be powered from external power. These switches are normally positioned in on. The power in use lights indicate when external power is supplying each system. Here we can see that external power is available and connected to both systems. Now touch an external power bus switch to move it to off. If this switch is moved to off, then its system is disconnected from the external power, as shown by the left power in use light not lit. The system has returned to normal, where the external power is supplying both systems. When the APU is started, the APU power available light will indicate that APU power is available. The APU bus switches connect the APU to the left and right systems if conditions allow. Now touch the right APU bus switch to connect the APU to the system. The power in use lights indicate when the APU is supplying power. The APU is now supplying power to the left and right sides, and external power is available, although not in use. To recap, the generator switches, when on, enable the generators to be connected to their systems. Once the generator comes up to speed, the APU bus relay opens and disconnects the APU generator and the generator relay closes. Note that the right APU power in use light goes off, the right generator off annunciation goes off, and that load is shown on the right engine generator load meter. When the second generator comes up to speed, again the APU generator is disconnected from that system. The generator relay closes. The left APU power in use light goes off. The left generator off annunciation goes off, and load is shown on the left engine generator load meter. The APU generator load meter displays 0. Note that APU power is still available. The APU generator off annunciation remains on as long as the APU is running, but not delivering electrical power. Although both electrical systems operate separately, they can be connected together using the AC cross-tie relay. When using external power, cross-tie can never occur. The APU can only cross-tie in flight, but the engine generators can cross-tie both on ground and in flight. So, let us first look at a cross-tie with engine generators. This switch on the electrical panel controls the function of the cross-tie. In auto, cross-tie is automatically controlled. In open, cross-tie is inhibited. If one generator fails, the other generator will then supply that side through the cross-tie relay, if the conditions so allow. Note that in this case there is no APU or external power available. Whenever cross-tie occurs, galley power is automatically disconnected to reduce the load on the single generator. Now touch the AC bus cross-tie switch to move it to open. The AC cross-tie relay can be held open by moving the switch to open. This is used to separate the systems when a malfunction occurs. With the switch in auto, the AC cross-tie relay may also be kept open by other factors, such as when one side has a short circuit. This prevents failure of the functioning side. This condition is shown by the AC cross-tie lockout annunciation. Now let's have a look at the operation of the APU cross-tie in flight. The APU generator can cross-tie in flight only. In this example, one engine generator has failed and the APU has been started. Note that the left APU bus switch is set to off. The reason for this procedure is to take advantage of the protection system of the AC cross-tie relay. So, if the other engine generator fails, the APU will be the only generator supplying power. Cross-tie can occur, allowing both systems to be powered. If landing with the APU cross-tie in operation, the cross-tie side will not be powered after touchdown. This may be very noticeable at night. Good. Yes. 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 Good. Good. This section will describe these power sources used in the DC system. The main DC power sources are 4 transformer rectifiers, 2 on the left system and 2 on the right. They're positioned in the forward accessory compartment in front of the flight deck. The 2 TRs will share the load supplying their DC buses. The right and left DC systems normally operate separately. The load of each transformer rectifier is monitored on a DC load meter. An indication on the load meter shows that the transformer rectifier is operational. Its operating limit is a maximum of 1.0. If one side's TRs are unserviceable, the 2 sides can be connected together via the DC cross-tie relay. The DC cross-tie switch controls this relay, which is normally open. The cross-tie function is not automatic. Now touch the DC cross-tie switch to move it to close. If set to close, the right side may supply the left side or vice versa. This will restore DC power to all the DC buses. Note that the load increased on the right DC load meters. If required, just one transformer rectifier is enough to energize the whole DC system. The batteries are made up of 2 14-volt batteries connected in series, giving 28 volts DC. They're positioned in the electrical and electronic compartment together with the battery charger. They supply some consumers directly and others providing the battery switches on. The battery switch is located on the overhead panel. The batteries can power certain vital equipment for up to 30 minutes, providing they're fully charged. The batteries are charged as soon as the right AC electrical system is energized and the battery switch is on. Charging the batteries is fully automatic, with a maximum charging current of 65 amps. Charging or discharging is displayed on the DC volt and amp meter when the BAT amp is selected. When the needle points to the left, the batteries are being charged. Remember, it points towards the pilot in charge. Charging occurs in pulses and is regulated to prevent the batteries from overheating. Correct. Correct. Yes. Yes. Well done. Done. Yes. Yes.